Welcome back to Chapter 3. This is Section 3.3, and it deals with mixtures of matter. So we are going to deal with some terms that you've already heard, but for some of you it could have been 2 years ago, possibly 3, so that is why we're going over it again. Mixtures are a combination of two or more pure substances in which each substance retains its individual chemical properties. So the pictures here show oil and water. Okay, you combine them together. You've probably done this at home. You know that oil will separate out from the water and they won't ever actually mix all the way together. So they retain their own chemical properties. They do not change. If you look at Italian dressing over there in the little bowl, you can see that all of the herbs and any veggies, it almost looks like carrots are in there, but I don't know what kind of Italian dressing that is. But it all retains its own chemical properties. The herbs don't just disappear into the mixture, they actually retain their properties. Okay, that's a mixture. Homogeneous or homogeneous mixtures are mixtures that have particles that are so small that different substances cannot be distinguished. So you're looking at the mixture and you can't see any individual particles. That's going to be a homogeneous mixture. They're also called solutions. And I have a solution here. Okay, it's, I don't even know what it is, but it's a yellow liquid. It is homogeneous. I cannot tell the difference, in case you can't get a good view. I cannot tell the difference between any of the particles. So that is why it's homogeneous. They can be liquids, solids, or gases. Solid solutions are a lot of times called alloys, and those are mixtures of metals. And a lot of times they do it to achieve stronger, durable, or lightweight materials, like what they use on airplanes. Can you think of any other alloys?
Your brass.
Yes.
And what's that other metal
Um,
one? Stainless steel.
Stainless steel is. Let's see. Baseball bats are made with alloys.
Oh.
So a lot of the metals that we see or actually use are alloys. Heterogeneous mixtures. These do not blend all the way throughout, so substances remain distinct. Colloids are one type of heterogeneous mixture, and they're intermediate particles, so they do not settle all the way out. And we talked about this in Science 1, but examples are going to be milk or glue. Can you think of any others? Fog. Fog is a good one. Okay. These demonstrate the Tyndall effect. Okay. So this is glue. You can tell it's glue because it is.
I think somebody opened it and it hardened.
It glued to the test tube. But if you were to shine a light through glue or milk, light would scatter. Think about headlights in fog. So if you're driving through fog, you'll see that it's a bright light in the cloud in front of you, and that's the Tyndall effect. Okay, suspensions are going to be larger particles that settle to the bottom. So orange juice with pulp. So some of you will say, what about orange juice without pulp? Well, if there are no distinguishable particles, then it could be a homogeneous mixture. But if it has the pulp that settles out, like the kind that I like to drink, then you're going to have a heterogeneous mixture. Italian dressing, normally you've got about 2 inches of herbs and spices at the bottom that you have to mix in. That's a suspension. So this is another example of a suspension. The particles aren't that large seeming, but it's 2 different liquids, and one is separating out from the other. So if you wanted to mix it together, you would have to shake it.
Go, shake it, shake it, shake it.
See?
Yay! And then you gotta wait, and it'll start going.
And then it settles. Oh, it's pretty fast. See?
Kind of like muddy
It'll
water.
Start going.
Yay!
Yes, river water, water in ponds and lakes, especially around here, are all heterogeneous mixtures. Okay, so we're talking about physical ways to separate mixtures. So you will be doing a lab in class, and it's one of our favorites because it makes you think. But you have to separate a mixture that has 3 different components to it. So one way that you might separate could be filtration. Filtration separates heterogeneous mixtures by size. Typically, this is if you have 2 different types of solids. Say you have pebbles and sand. you could run it through a filter to get all of the sand out and keep the gravel above. Or you could take a liquid and a solid. You could pour the liquid and the solid into a funnel filter paper. You'll keep the solid behind and you'll have the filtrate underneath. Okay. Crystallization. This separates homogeneous mixtures by boiling off liquids, leaving a solid. I show a picture here of rock candy. You don't actually boil this, you just kind of let it sit. But what's happening is when the liquid evaporates off, then you're left with the crystals underneath. Have you ever made rock candy?
No, I'm gonna have to try it.
It was my 7th grade science fair project.
Nice.
Okay, distillation is another method to separate mixtures. So you're going to separate a homogeneous mixture of liquids by their boiling points, and I'll demonstrate this in class. Do you do so? So our apparatus looks a lot like the picture shown here. You're going to have a flask at the top. You're going to have a tube called a condensing tube, and it has an inside tube where the liquid's actually going to go, and it has an outside tube where you can run water to make it cooler. So from the last section, you know that condensation happens when gases cool down into liquids. So
we're gonna boil things off by their boil. So these are two liquids
Yes.
in the same container.
yes.
And one's gonna boil first.
Mm-hmm.
And the one that boils first, we can actually collect it first.
Yes.
All right, and then we're left with the other one behind that hasn't boiled yet.
Yes. So the
Excellent.
idea behind distillation is you can get two pure substances on each side. So you'll have the one that didn't boil off and the one that did.
Awesome.
Chromatography separates homogeneous mixtures by polarity and size. Polarity just means positive and negative charges. You want to talk about that one?
With this one, what we're going to do is we have a black felt tip marker, usually water-based. Otherwise, it's not going to work.
No.
The water will take it and it will move from the capillary action inside of the paper, and it will move up. The heavier ones will stay at the bottom, and the smaller particles, which are lighter, will travel all the way to the top. So looking at this one, your yellow one is going to be your lighter size of the particle because it traveled the farthest.
Mm-hmm. If you leave a piece of paper in water or a piece of cloth, it's going to get wet at the end eventually because the water travels through. That's what's happening.
Yeah, or paper towel. You know how you get one corner of paper towel and then it just kind of keeps going.
Mm-hmm. Same idea. Okay, that's all for section 3. So we'll see you next time.
Bye.